Okay, right. So here is a statics question. So we've got a ladder and it's leaning against a peg there. Right. So it says the ladder has a mass of m and a length of 3a, and it's 6a, and it's uniform. So that means we have the mass here of mg, okay, and that's at 3a. It's resting against our peg, so that's going to have a normal reaction there. It's touching the ground, so that's going to have a reaction there. We're given that the angle alpha, sine alpha, so we know that the opposite side is 4 and the hypotenuse is 5. So that tells us from our Pythagorean triple that the adjacent is 3, and therefore we know that cosine of alpha is 3 over 5 and tan of alpha is 4 over 5. Okay, we've got a coefficient of friction between the ladder and the ground is mu, and it's in limiting equilibrium. So that means that F must be equal to mu r. Right, so now showing this, we're going to show the magnitude of the force exerted on the ladder by the rail at C is 9 mg over 25. Right, so follow the same way we solve all these problems. So first thing I'm going to do is I'm going to take moments about A. Okay, and I'm going to then find N, the reaction at C. Okay, so let's split them up clockwise and anti-clockwise. So my force pushing it this way is going to be anti-clockwise, and my force pushing it this way is going to be clockwise. So clockwise, I've got the weight. So that means I've got mg times 3a, the distance from the pivot, and then this weight is not perpendicular. So I'm going to put this here. I know that that is alpha. So that means that I've got mg 3a times cos of alpha. And anti-clockwise, all I've got is my reaction force, which is 5a from my pivot. So that's 5a times 9. Okay. So we know what cos of alpha is. That's 3/5. So I've got mg times 3a times 3/5 is equal to 5a times n. And now if I do that, I've got 3a times 3, that's 9a over 5 mg, and I'm going to divide that by 5a to get that, and then that gives me 9 over 25 mg equals n, which is part A taken care of. Right, what's the next thing we do? Because I've got to work out the coefficient of friction. Okay, well, then the second thing to do is I'm going to find out the reaction R. So I'm going to go vertically to find R. Okay, so what have I got? I'm going to resolve in this direction. Okay, now R is going up. I've got mg going down. And the only other force that's going up is going to be my reaction N at C, but I want to work out the vertical component of that force, so I'm going to resolve in that direction. Now this is where we have to think a little bit. So if I draw a horizontal line there, I know that if this is alpha, then this is alpha, which means that this is 90 minus alpha, and this is also alpha. Right, so now that means that going upwards, I've also got n times cos of alpha. And let's substitute in what I know. So R equals mg minus, well, my n was 9 over 25 mg, and my cos alpha was 3 over 5, which means that R is equal to 98 over 125 mg. So now I've got R. 3. Now I've done the vertical, I'm going to do the horizontal. And the horizontal is going to tell me mu. Okay. So in the horizontal plane, I have got the reaction at C with the horizontal component, and I've got friction, and that's it. So that means that my mu R is equal to N sine alpha. Okay, because I know this alpha here, so I'm going to use sine rather than cosine because I'm resolving in the horizontal. So now I've got that. Okay, again, I can substitute in my N. So I know that mu times R was 98 over 125 mg, is equal to N times sine alpha, which is 4/5. So 9 over 25 mg times 4/5, which means that I can cancel out mg on both sides. Let me tidy things up a bit. So now that means that 9 times 4 over 5, so no, 20, I've got 36 over 125 is equal to mu times 98 over 125, and that means that my mu is equal to 18 over 49, which is about 0.36723 sig figs. And that is B taken care of. So the whenever we do one of these statistics questions, it's basically the same idea. I need to find a reaction. I need to find a reaction force to find my frictional force, or basically I'm resolving vertically and horizontally, and at some point I'm going to have a turning force. In this case, the contact force is found by taking that moment about A.